Okay, so the cosine ratio is adjacent over hypotenuse, and the secant is just the inverse of that, or the reciprocal of that, which is the hypotenuse over the adjacent. And really the only reason to use the secant is it might make the algebra a little bit simpler to work with when if the hypotenuse is the unknown, you might prefer to have that in the numerator. It just makes it a little bit simpler. And that's the basic reason in high school level geometry why you might want to use the secant ratio. For our students, for the most part, I would just encourage you just to stick with the cosine ratio. So that is, anytime that you know the angle measure and you are trying to solve for either the adjacent side or the hypotenuse, then you would use the cosine. If you know both the adjacent side and the hypotenuse and you want to find the angle measure, that's when you'd use the inverse cosine. So this function, the inverse function, and the cosine ratio, they're basically, all they're really doing when you use them on a calculator is they're going to a big lookup table in a database somewhere, and they're saying, oh, do you know the ratio? If you know the ratio, then I'll use the inverse cosine to look up the angle measure. You know, this is used. I don't know my angle measure, and I need to find it, and I'm going to use the ratio to look it up, and that's what the inverse cosine function does. On the other hand, if I know the angle measure and I'm trying to figure out what the ratio is or one of the missing sides, then I would just use the regular cosine function. So in this assignment here, you're going to practice this, and it's not really much different from what you've done with tangent and sine so far. So you're basically dealing with problems where you have a right triangle, and like in this case here, you have the angle measure. Here's the adjacent side, so it's the side that is not the hypotenuse, that is a part of the angle, and here's the hypotenuse. So the adjacent over the hypotenuse, in this case, would be 300 over 500, right? And so what you're going to be doing here is you're going to be, exploring and writing this out. So, your length of your side adjacent, again, here's the angle measure, angle A. They're giving you that as the reference angle. So therefore, the adjacent side is AC and the hypotenuse is AB, and you'd fill that in there. Once you know the numbers, you will take the numbers from those three triangles up in question 1, and you will first write the ratio. So remember that 300 divided by 500. You're going to write that 300 over 500, and then you're going to use your calculator, and you will find the, you'll turn it into a decimal. So 300 divided by 500 is 0.6. They want you to round it, so they want you to look at this as a decimal. Generally speaking, it's better just to leave it and not do any rounding. But right now, just for the purposes of exploring what happens to cosine, they want you to do that for both angle measures, and they want you to round and get decimal values because it's easier with a decimal value to do some comparisons. Okay, so you're going to do this. You're going to explore just like we did before, and you're going to figure out what happens to the cosine value of an angle as the measure of the angle increases. So if you look here, the angle is increasing. You can see that as we, let's see, we start here. As we increase this angle, okay, from 48 degrees up to 53 degrees up to 60 degrees, and they're fixing here the hypotenuse at a fixed 500. You can see that what's happening in order to keep this side fixed is that what we're doing, in order to keep the hypotenuse fixed, what we're doing is we're having to make, as this gets bigger, we're having to make the adjacent side smaller. So it goes from 335 feet down to 300 feet, down to 250 feet. And if you were going to keep it at 500 feet, the only way to do that when you open up this angle is to bring this in closer and closer and closer. If you had an 80-degree angle and this was still 500 feet, this would be a very, very small side here. So in essence, this is the numerator, that's the denominator. So as you're opening up the angle, as you're making the angle wider, the ratio is getting smaller. It's getting smaller. So that's the idea here with question number 6. So now they just want you to calculate these. And notice in number 7, they are not asking you to round or use your decimal. we want to really, especially for the next few problems and going forward, we want to get used to not having to have a decimal answer. We're going to use these radicals and leave them in the radical form. I think that's really important to remember. Okay, so one of the things about all of these kinds of word problems is it's best to get practiced at drawing a diagram. We're really good at solving problems that we can see visually. So, you know, drawing a diagram means making that right triangle that looks like, here's the guy wire coming down off of a tower. There's a tower and a guy wire, and it forms a right triangle. So they want you to draw the diagram out here. And then after you draw the diagram out, you're going to fill in, you know, the wire 600 feet long, that's the hypotenuse, and there's a 55-degree angle. So what would then be the measure of the adjacent? We would use cosine for that, right? So the cosine of 55 equals the adjacent, which we'd call x, over 600. And then to solve for it, you multiply both sides by 600. So x is equal to 600 times cosine of 55. And you're going to do the same thing here. You recognize there is a diagram already, so we can see a right triangle. And, you know, 65 feet is the hypotenuse. And 56 feet is the height of where the building touches the ladder. And what they're asking for, I did notice a couple kids here thinking, assuming that we're looking for this angle. We're not looking for this angle here. It does say, you know, use the cosine ratio to compute the measure of the angle formed where the ladder touches the top of the building. So you're looking for this measure here. That makes this the adjacent side and this the hypotenuse, because this is the new reference angle. So you're going to use that, and here you're going to go ahead and calculate all three of the ratios. They've given you all three side lengths, and this is the reference angle. So all they want you to do is show that you still remember how to find sine, right? Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse, and the tangent, which is opposite over adjacent. And the only thing I have to remind you of is that we want to reduce when possible. So if I'm putting 6 over 12, that can be reduced to 1 over 2. And we want to remember to rationalize our denominator. Your calculators may help you do that, but we do not want to leave 6 root 3 in the denominator. So and this is really important for this tangent problem, because what's going to happen is if you do this correctly, once you get this reduced right, you look at the value of sine over the value of cosine, you're going to see something about the value of sine and cosine that you want to compare to the value of the tangent. Okay, I'm not going to do that for you, but some basic algebra, and you should notice something very, very clear about that relationship. Okay. And in here, there's a little bit of algebra you can do to show why this is the case, which I'm not going to do with you right now, but I'm happy to help you with if you have a question. So now we're going to get into secant, and of course we're just going hypotenuse over adjacent, so AB over AC in the case of reference angle A. And proving algebraically, this is done just like we did it with sine and tangent earlier. Or rather with cosecant and sine, and with the cotangent and tangent. We've done this exact same thing in those other lessons, so we're not going to do it again. And you're going to think about what happens as the angle increases. Of course, the hypotenuse is now in the numerator, so it's going to have an inverse effect. Instead of the ratio going decreasing, it is going to increase, and that's what you need to know there. If you don't know the secant button, or if there is no secant button on a calculator you're using, you can just remember that you can always put it in as 1 over the cosine. Okay? All right. So here you're going to practice finding the hypotenuse. And again, this is when you would want to use the secant, or, you know, it might make sense to use the secant because your ratio of the secant of 21 is x over 4689.2. And so you can just multiply both sides by 4,689.2, and you would have 4689.2 times the secant of 21 is equal to x, and that might be a little bit easier to use. Okay, you're going to do it, actually, they want you to do it first in the cosine, where you have to put the x in the denominator, and then you have an extra step, and then the secant, where the x is in the numerator, and it's a little bit easier, and you should notice that. Okay. Now we do the inverse cosine. So here we want to find the measure of angle A. This is the adjacent. This is the hypotenuse. So the inverse cosine of 16 over 18 is going to give you the measure of the angle. And the same thing here, if you just put the inverse cosine of 2 over 7, you will find the measure of angle A. And you just got to use your calculator for that. And you're going to do some practice problems with that. And here you have a problem, and it's got a really nice diagram to kind of help you figure it out. You have a hypotenuse, you have an adjacent side, and you're trying to find the angle measure. So that's the inverse cosine again. Now this problem was a little bit of a challenge for a lot of kids. Let's kind of just go through it real quick. But the biker rode their bike for 3 hours and 12 miles here, and then rode for another 2 hours, 8 miles there. They want to know what is the total distance. And we know this angle is 65. What we don't know is any of these measurements here, x and y, or this measurement z. Now z is a hypotenuse of this right triangle. And so we've got to find the distance, the horizontal distance in this diagram, and the vertical distance that makes up that hypotenuse of 8 miles. And the way you do that is you'd realize, well, these two angles, this little one right here and this one right here, are complementary. Together they make 90 degrees. And we know that because this one's a 90, right, perpendicular, and this is 180 altogether. So this is 90. So 90 take away 65 should give you this angle measure. Use this angle measure along with the cosine to solve for the cosine. So x is equal to the 8, the hypotenuse, times the cosine of this angle measure. You'll get x. And then you can use Pythagorean theorem if you want to solve for y. Or your other option is, of course, then to use the sine function. So sine, so this angle here, the opposite side, is equal to 8 times the sine of this angle measure. You'll have x and y. And you add x to 12, and you've got this leg of a right triangle. You have y, that's the other leg of the right triangle, and you use those two with Pythagorean theorem, and you can solve for the length of z. So it's a few steps in there, but nothing too overly complicated if you understand sine and cosine. So now you're just matching up which of these goes with which of these, and then we have, let's see, arc sine and arc tangent, arc cosine. I don't know if I've mentioned that, but you're essentially talking about inverse sine, cosine, and tangent. So these are the inverse symbols, and they call it sometimes arc, sine, cosine, and tangent. And now you just got to make sure you know your ratios. And then the last thing is, in the last problem set, let's see, lesson 9.3, they gave you a diagram, and they labeled on the diagram what was known and what was unknown, and then you had to figure out which function to use. In this case, they're not giving you the diagram. So my advice, I found a lot of kids stuck on this. My advice is to draw a right triangle for each one of these and label the known information. So if it says hypotenuse, write on the hypotenuse, write known, and on the opposite side, write known. And then you think, aha, if I know my hypotenuse and my opposite, those two form the which function? That would be my opposite over hypotenuse is sine. And if I want to find the unknown reference angle, then I'm going to use the inverse of sine. So the function uses inverse of sine. And these will be easier if you make your right triangles, label what's known, put x's for what needs to be solved, and think about the relationships to know which function should be used. Honestly, it's just really, really helpful to have to be able to get into the habit of drawing right triangles for any word problems and looking at the right triangles. It's so much easier than trying to decode the words and keep it all in your mind. So that is a wrap-up of lesson 9.4.